Hi guys, we are on concept 7, which is writing equations. This is an important concept. You will see questions very similar to this that are going to be on the map test. So pay attention, take good notes, and stop and ask questions if you need help. We are going to determine whether or not a value is a solution to an equation. An equation is a mathematical statement that shows that two expressions are equal. An equation is different from an expression because an equation has an equal sign. So far, everything we've worked with has been expressions. They do not have equal signs. But now with the equations, they will. An equation may or may not have a variable, and when there is a variable in the equation, a solution is a value for the equation that makes it true. Here are some examples of expressions and equations. Using numbers, an expression would just be 5 plus 4. But an equation would be 5 plus 4 equals 9. Again, it has the equal sign in the word in equations. And you kind of hear equal in the word equation. It kind of gives you a clue that you'll have an equal sign. When you're using words, we have written expressions and equations. So this is a number plus 4. That is how you would write the expression using words. But an equation in words would be a number plus 4 is 9. So is taking the place of the equal sign when you're using words. In algebra, using algebraic numbers and variables, you would have n plus 4. That's an expression. But an equation would be n plus 4 equals 9. Again, you will up here and above it says that it may or may not contain variables. So this particular example, there are no variables. In this particular example, there is a variable. But the key here is they both have equal signs. Equations have equal signs. So let's look at an example. It says determine whether the given value is a solution of the equation. And this is the type of question that you will see on the map test. It tells me the equation is x plus 9 equals 15. And then it tells me x is 6. So I'm going to substitute 6 in where I see the variable x. I'm going to rewrite it. 6 plus 9 equals 15. So all I did was replace 6 where the x was. And now I'm going to show what is on one side of the equal sign is equal to what's on the other side of the equal sign. If that is true, then that is a solution to the equation. So is 6 plus 9 15? Yes. And the other side of the equal sign is 15. So yes, 6 is a solution to this equation because both sides of the equal sign equal 15. If it told me that x was 5, let's just say that, and I put 5 in here, is 5 plus 9 15? No, it would show 14 equals 15, and that is not true. So if it said x was 5, that would not be a solution to the equation. Okay, that was just a little example of when it is not. Okay, in this particular case, x as 6 is a solution because both sides of the equal sign show 15. Okay, let's look at another example. Y divided by 4 equals 32. And it tells me that y is 8. I'm going to substitute 8 in for y and rewrite the problem. I'm going to solve what's on this side of the equation and see if it equals what's on this side of the equation. So 8 divided by 4 is 2. Is that equal to 32? No. So my answer is no. Y equals 8 is not a solution. Okay, let's try another example. Remember, a number and a variable right next to each other. It's called a coefficient. The coefficient and the variable right next to each other represents multiplication. So this is 8 times x equals 72, and it tells me that x is 9. So if I substitute it in, I have to show multiplication. I cannot just put 8 and a 9 and assume someone knows it's multiplication. I have to put some multiplication symbol there. I'm going to use a dot. and I get this. So I'm going to solve what's on this side and prove that it equals what's on this side. 8 times 9 is 72. So both sides of the equal sign equal the same number. So yes, x equals 9 is a solution to this equation. Okay? All right, I want you to pause the video. I want you to try your turn. When you're ready to see the answers, click play to see them. Okay, let's see how you did. I showed my work for each one. I'm hoping you did the same. We're not going to do it in our head and just write a yes or no answer. It does say show your work, like the examples above. So I have to show that both sides of the equal sign equal the same number, or that they don't equal the same number. That is what I'm showing. So I know that 11 equals n plus 6, and n is 5. So I came over here, I rewrote the problem, and instead of using n, I substituted 5n. So now I solved over here and said 5 plus 6 is 11. So yes, 11 equals 11. When n is 5, that is a solution to the equation. Look at number 2. Y minus 6 equals 24. And it tells me y is 18. So I put 18 in. 18 minus 6 equals 24. When I solved on this side, 18 minus 6 is 12. It is not equal to 24. Notice I put the slash through the equal sign to show that it is not equal. And I came over here and said, no, this is not a solution. 18 is not a solution for y to make that equation true. Number 3. X divided by 9 equals 4. If I substitute 36 in for x, I rewrite it. 36 divided by 9 is 4. So yes, x as 36 is a solution for the equation. And the last one, 15 times t equals 100. Again, I have to show multiplication. This time I chose to use parentheses. So I said 15 times 6 equals 100. 15 times 6 is 90, so no, it is not equal to 100. This is not a solution. T cannot be 6. Let's look at your second page of notes. You see that we are going to write equations to represent real-world situations. Now, we've already written expressions to represent real-world situations, so this is going to be very similar. The only difference is you're going to have an equal sign. So let's look at example 2. It says Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points. Write an equation to represent this situation. Well, sometimes it's helpful to actually write out headings or kind of like a model of how you would get your answer. So I know that Mark's points plus his teammates' points should equal their total points. So then I can fill in numbers down here. Do I know how many points Mark scored? Yes, it told me 17. Do I know how many his teammates scored? No, his teammates as a group scored P points. So I'm just going to put the variable P in. And I know that it has to equal the total points that they scored. To get the total points, you have to see the scoreboard, and the scoreboard shows the home team has 46 points, and the guests have 42 points. So this tells me right here that the total points that Mark and his teammates scored together was 46 points. So this is a scoreboard that you can't see. So I'm drawing it out for you. All right, I'm going to have you take a second and pause the video. You are going to try 5, 6, 7, and 8. All you're doing is writing an equation to match the story. You're not solving anything, you're just writing an equation. When you're ready to see the answers, push play. All right, let's see how you did. The first one, Marilyn has a fish tank that contains 38 fish. I know that that's going to be the total number of fish. There are 9 goldfish and F other fish. So together, the goldfish and the other fish make up the total of 38. This would be an addition equation. F plus 9 or 9 plus F equals 38. If you wrote that with these two reversed, that is fine. That's just using the commutative property. The commutative property says that you can write addition and like a turnaround fact. Okay, let's look at number 6. Number 6 says, Juanita has 102 beads to make N necklaces. Each necklace will have 17 beads. My key word that helped me was each. If each necklace needs 17 beads, I'm going to take 17 times the number of necklaces she's going to make, and it's going to equal 102 beads that she's going to use. You could have done this differently. You could have done this as 102 divided by N equals 17. So if you wrote it as a division problem, that's fine as well, but it would have to look like this. As I know that I could take this number, divide it by this to get the 17. Okay, so you could do 102 beads divided between the necklaces that she's going to make, we don't know how many, will equal 17 beads per necklace. Okay, look at number 7. Number 7 says, Craig is C years old. His 12-year-old sister, Caitlin, is 3 years younger than him. So I'm going to take Craig. I don't know how old Craig is, but I know his sister is 3 years younger. So I'm going to take Craig's age and subtract 3 from it, and that will equal Caitlin. And I know Caitlin's age. She's 12. So C minus 3 equals 12. And the last one, Kim rented skates for H hours. The rental fee was $2 per hour. That's a key word for me. And she paid a total of 8. I know the total is going to be what it equals. So $2 times however many hours equals the $8 that she spent. Okay? I know these notes are long. There's one more section where we're going to write an equation and check for solution. So we're going to take the two things we just did and combine them into one problem. Okay, let's look at example 3. It says Sarah used a gift card to buy $47 worth of groceries. Now she has $18 left on her gift card. Write an equation to represent the situation. Use your equation to determine whether Sarah had $65 or $59 on the gift card before she bought the groceries. So step 1, this is what we did in the beginning. It's often easier to sort your information out when you kind of have an idea of how your problem works. So I know I have a gift card that has an amount on it. I'm going to take away the amount that I'm going to spend at the grocery store, and it's going to equal what's left on the card. So I've used these words to kind of help me organize my problem. So now I'm going to start with the amount on the card. Do I know the amount that's on the card? Step 2 says to write the equation using variables. I don't know it. I don't know what she started with. That's what my whole question is. So I'm just going to use X. Okay? I'm going to subtract the amount that she spent. Well, we know it says that she used a gift card and bought $47 worth. So she spent $47 at the grocery store. And it says that now she has $18 left. That tells me what's left on the card. Okay? Step 3 says substitute 59 and 65 in for X to see which is true. So if I put 59 here minus 47, would it equal 18? If you can't do that in your head, you can go off to the side and do 59 minus 47. 9 minus 7, I can tell, is not going to equal 18. I get 12. So 59 is not going to be a solution to the equation. So now I'm going to try 65. If I put 65 in for X and subtract 47, will it equal 18? I'm going to come over here to the side, show my work. 65 minus 47, I have to borrow. 15 minus 7 is 8. 5 minus 4 is 1. Yes, it does equal 18. So 65 is the solution to the equation. She had $65 on the card to begin with. She spent $47 at the grocery store, and now she has $18 left. Okay, you're going to try 2 problems on your own. I want you to do number 9 and number 10, pause the video, show all of your work just like I did, and then hit play to see the answers. Okay, I'm going to show you all of my work. On Saturday morning, Owen earned $24 for mowing lawns, and by the end of the afternoon, he had earned a total of $62. So here are my 2 numbers, and I know that this is his morning. So to write an equation, here's what I wrote to kind of help me plug numbers in. His morning money plus his afternoon money equals the total money that he earned for the day. So when I go to plug my numbers in, it says that he earned $24 in the morning. I don't know what he earned in the afternoon, so I put a variable X there, but I do know his total was $62 for the day. So now I have to plug it in. I rewrote my equation over here, so my equation is 24 plus X equals 62. And now I have to determine, did he earn $38 or $31 Saturday afternoon? Well, I started with 38, I plugged it in, and I did 24 plus 38 equals 62. And I found out, yes, that is the solution. Once I realized that they were equal to each other, then I didn't even try 31. I knew that that was my solution. So Owen earned $38 on Saturday afternoon. Okay, let's look at number 10. Okay, on this one, it says that Sam paid $132 for 6 DVDs. Write an equation. Well, I know that he paid this much for a total of 6 CDs. So I know that's the total amount that he paid. Here are the 6 DVDs, but the piece I don't know is what did the DVDs cost, each one. So I came over here and said, if he buys 6 of them, we don't know the price, but I would multiply 6 times the price. And it should equal $132. So here's the number of DVDs times the price of them, which equals the total. So I plugged my numbers in. Here's the number of DVDs, here's the total. The part I don't know is the price. So then I had to plug in to see if my which one was a solution. Is it going to be $17 or $22? So I wrote this one out and I said 6 CDs, or DVDs, sorry, and they each cost $17. Does that equal 132? It equals 102. No, that is not a solution. So then I tried $22 times 6. So if each DVD was $22 and I bought 6 of them, it does equal $132. So yes, 22 is the solution to the equation. Each DVD has to cost $22.